During the Renaissance, the ideas regarding the positioning of our solar system took a better shape, which set the stage for the new discoveries concerning gravity. The first person who became interested in gravity was Sir Isaac Newton, physicist and mathematician. This happened one day when he was sitting under an apple tree when suddenly an apple fell and hit him on the head. This left him with a sore head and an extraordinary idea about what is gravity and how it works. After this occurrence, Newton began with his studies of gravity and came up with the law of universal gravitation. In the following video, we will observe how gravity causes acceleration both in freefall and projectile motion. The purpose of this project is to prove that the acceleration due to gravity is equal to -9.8 meters per second squared, and is demonstrated by using the program LoggerPro. Materials: small plastic ball, table or object that measures 0.93 meters, meter stick, camera, computer with LoggerPro and Movie Maker programs installed. Procedure for making the video: find a table or object from where you can throw a ball that measures 0.93 meters. For the freefall video, take the ball and drop it in the straight line from the top of the table or object. Record with a camera. For the projectile motion video, take the ball and throw it with a little force to the X direction. Record with a camera. Download the videos to the computer and then make the analysis using LoggerPro. Freefall. To analyze the data, you open the video using LoggerPro. Then, you measure from the top of the table to the floor that is equal to 0.93 meters. When you're done making the measurements, you'll trace the motion of the ball as it passes through the different state fragments. When you finish, you'll have the different graphs analyzed. Synchronize freefall video. This position time graph shows a curve because the object is accelerating while falling in a negative y direction. This velocity time graph shows a non-vertical, non-horizontal line, which has a slope of -9.51 meters per second squared, meaning that we were close to the acceleration due to gravity, that is -9.8 meters per second squared. Projectile motion video. To analyze the data, you open the video using LoggerPro. Then, using the measure stick, you measured from the top of the table to the floor that is equal to 0.93 meters. When you're done with the measurements, you're going to trace the motion with the dot option as it passes through the different fragments. Synchronize projectile motion video. This position time graph shows a curve because the object is accelerating in a y direction. This velocity time graph shows a non-vertical, non-horizontal line with a slope of -9.53 meters per second, which shows that we were close to the acceleration due to gravity, which is -9.8 meters per second squared. In conclusion, after doing the video analysis, we calculated for freefall acceleration -9.51 meters per second squared, and for projectile acceleration -9.53 meters per second squared. With these very accurate results, we can confirm and conclude that the acceleration due to gravity for all free-falling unlaunched objects is -9.8 meters per second squared. Reference list.